Hi, everyone, and welcome to our webinar today, Computer Science for All through Inclusive Design. I'm Amaya Webster. I manage the diagram communities, and I'm also the project manager for Benetech Labs. I'm thrilled that you guys can all join us today. I'm going to go over a few logistics before we really jump into the webinar itself. We do have a lot of people who have signed up to hear our presentation, so make sure that everybody but the presenters are muted. If you have questions, you could enter them in the chat window or save them until the end. After we finish the presentation portion, we're going to try to leave about 5 to 10 minutes to answer questions. If we don't have time to go through all of the questions, we will have a transcript of the ones that were asked and not answered that we will answer and then send out after the fact. I am recording the webinar, so once we've gotten that captioned, we'll post it to our website as well as email it out to the registrants list. And we'll also post the slide deck to our website, and I'll alert them to that once it's happened. I think that's about it for logistics. I'd like to kick us off by introducing our presenters today. Andreas Stefik, who is an assistant professor in computer science at the University of Nevada, Las Vegas. Dina Brahm, who is the founder and president of All Consortium, and Richard Ladner, who is a professor in the Department of Computer Science and Engineering at the University of Washington. And to give you a little bit of background on each of them, Andreas has spent the last decade creating technologies that make it easier for people, including those with disabilities, to write computer software. With grants from the National Science Foundation, he's helped to establish the first national educational infrastructure for blind or visually impaired students to learn computer science. He's also the inventor of Quorum, which is the first evidence-oriented programming language. He is a PI on the NSF-funded Access CS10K grant that is helping CS10K projects prepare K-12 teachers to be more inclusive in their computing science courses with students with disabilities. Last year, he was honored with the 2016 White House Champions of Change Award in Computer Science Education. And he's one of Diagram's newest community members and has wasted no time in contributing his expertise by joining us today to present. So we're ecstatic to have him and really looking forward to collaborating more in the future. Next, we have Sina, who is a longtime member of the Diagram community and one of the co-chairs of our developers work group. He's an accessibility consultant, researcher, and entrepreneur, as well as the founder of Access Consulting. He has a really strong background in computer science and holds undergraduate and graduate degrees in the field. He is recognized as an expert in accessibility and enjoys collaborating both with colleagues in the field and individuals of diverse professions to devise innovative and user-centered solutions to difficult real-world problems, which is what he'll be talking with today. In 2012, he was recognized as a White House Champion of Change for his work enabling users with disabilities to succeed in STEM, so science, technology, engineering, and math. And in 2015, the international accessibility community recognized him as an emerging leader in digital accessibility at the annual Knowability Community Heroes of Accessibility Award. This year, he's going to be a guest co-chair of the museum and the web conference. So as you can see, quite the busy bee, and we're thrilled that he was able to find time to be with us here today. So thank you very much, Thea. And last but very much not least, we have Richard, who's a long-standing relationship with Benetech. He's actually been a part of the Diagram community basically since inception. Some of you might be familiar with the work he did on tactile graphics with the voice. He also gave a webinar on that for us. Both his work on tactile graphics for voice and the webinar available on our website for anybody interested. He's currently serving on our General Advisory Committee as well as our Technical Advisory Subcommittee. His research is in the area of accessible computing, which is a sub-area of human-computer interaction. He's won an impressive number of awards over the course of his career, including the ACM SIG-Chi Social Impact Award and the ACM SIG Access Award for outstanding contributions to computing and accessibility. So we're really lucky to have him as part of the community and delighted that he's here today. So thank you, Richard, thank you, Tina, and thank you, Andrea. we're really, really happy to have you all. Honored that we began to do this. And with that, I will turn the floor over to Richard to get us started on this webinar. You might have to wait a sec while he unmutes.
Can you hear me?
Yes, you can.
Oh, yes. Great. And can I advance the slides? Is that how it'll work?
Yes.
Okay. So first I want to talk about this Computer Science for All initiative. And it's actually been going on for a number of years, maybe 7 or 8 years, through the National Science Foundation under the title Computer Science 10K, trying to get more computer science into K-12 education. And it kind of hit a top when President Obama announced the Computer Science for All initiative last year, in February or January last year. And his State of the Union address, he said, in the coming years, we shall build on that progress by offering every student the hands-on computer science and math classes that make them job ready for day one. So, so the Computer Science for All initiative is in full bore now, even though Obama has left office. If you do a search for Computer Science for All, you'll find the information about it on the White House website. It's still there, so please take a look at that. To start with, I just want to talk about why computer science in K through 12 is so important. And I just put up a figure here that talks about, it's from the Bureau of Labor Statistics, and it describes new U.S. STEM jobs through 2022. STEM means science, technology, engineering, and mathematics. Typically, a job like this would require a bachelor's degree or more, and in many fields, mathematics, engineering, physical sciences, life sciences, and computing. And the figure shows that for new jobs through 2022, 74% will be computing jobs. Only 3% are life sciences. So that's not counting medicine now. Physical sciences, 3%. That would be like physics and chemistry. Engineering, 16%, and mathematics, 4%. And if you look at the 74%, not quite half are software development. That's programming, writing programs. And for the most part, people with disabilities can write programs. They can use their screen readers if they're blind. You're in an office by yourself sometimes, or working on small teams. It doesn't require a lot of physical labor. And I know many programmers and software developers who have disabilities around the world. So the point here is that if you're going to go into a STEM field, computing is a field to go into. And if you look at the actual numbers, the number of job openings in the next 10 years in computing will be about 1.2 million jobs in the United States. And we're only producing about 40,000 bachelor's degrees in computing every year. So there is a huge gap there that's being filled by people from overseas generally. So what are the major efforts that are going on right now? And I've listed 4 on this slide. This is slide 4. One is exploring computer science, which is out of UCLA. It's around the nation. They're doing professional training all the time to try and retrain teachers in other fields to teach elementary computer science. This would be like a 10th grade, 9th grade, 10th grade course. Second is AP Computer Science Principles, which is just for the first year being taught this year. It's a general computer science course. It's not just a coding course. It's very popular. There's about 38,000 students taking AP Computer Science Principles this year around the nation. There's the more traditional AP Computer Science A, and I don't know the number of students taking it around the nation this year. I haven't heard, but it's been over a number of years declining in interest. It's basically a programming course in Java, and it's been fairly stable. I think it's increased in the last couple of years, though. And then a fourth effort is Bootstrap, which is, again, this is a sort of combining math and computer science, and it's very popular around the nation. So these are the four sort of major efforts to try and get computer science into K through 12. So if I move to the next slide, slide 5, who are the organizations working on this most heavily? Well, there's a National Science Foundation, which has funded tens of millions of dollars toward this goal of getting more computer science in K through 12. There's code.org, which hosts the Hour of Code. There's currently about 200 activities for people to do on Hour of Code, and they're a major player in this. Also, the Computer Science Teachers Association, which is a growing organization of more dedicated teachers that are teaching computer science around the nation, even before, many of them even before the Computer Science for All initiative came about. Also, there's something called the Computer Science for All, or CS4 All Consortium, which is basically all the players. And there's 220 members currently, and it's growing every day. But I wanted to highlight 3 that are concerned about students with disabilities. The first is Access CS4 All, which is my project in Stefik. Stefik and I work together on that. And the second one is bringing AP CSP to students with learning differences at the Walcott School, which is led by Sarah Willie, and she's on this call, I believe. And then a third one that I found in CS4 All Consortium is Deaf Kids Code out of Indiana. And so far there's only 3, and I'm hoping that this will be, by the end of this year, 2017, maybe 10 or 15. So we really want to build up this community of people that want to include students with disabilities in this great national effort. So I want to talk briefly about our project, the one that Andreas Stefik and I are working on, along with Cheryl Bergstaller, who's the director of the Do It Center at the University of Washington. We call it now Access CS4 All. It's a joint effort between our 2 universities, University of Washington and University of Nevada, Las Vegas, and it's only 2 years old. We're just getting off the ground. We just had a wonderful workshop a couple of days ago at a conference, computer science education conference, so we're really moving along. We have a singular goal, which is on slide 8, to increase the participation and success of students with disabilities in K through 12 computer science, and there's a couple of pictures of students that we've worked with directly. Most of our efforts are toward institutional change and trying to get more teachers able to include students with disabilities, and also on the technology and improving the technology for access. So I'm going to pass it on now to Sina. So I gave you an introduction to this great national effort.
All right, and Amaya, just a quick sound check. You can hear me okay?
A little louder.
Sure. All right, is this any better? That should be better. Sufficient. Excellent. Thanks, Richard. I really appreciate it. Essentially, I wanted to talk about 3 things, and I'll just give you a cue to advance the slides. Wanted to go over some existing solutions used by users today, kind of lay out the landscape a little bit there for developers with disabilities and students with disabilities who want to get into programming and in computer science, and talk about the problem areas a little bit. And then give a shout out to incorporating inclusive design into these efforts, which is what Richard and Stefik's and other folks' work concentrates on. So next slide. So existing solutions right now, and these are only a few that I've got on this slide, and there are others, can be broken down, we can by functional ability, to just break it down one way. So, for example, someone who's blind, as Richard mentioned earlier, might use a screen reader, right? And they might also use a Braille display, although sometimes there's a matter, some folks are more comfortable with Braille. There's Braille literacy issues as well. But these are some very common tools that are used by, let's say, a blind developer. However, the problem doesn't just stop there. Okay, well, programming is writing text into a text field and compiling your code, and if your computer can read it to you, then we've solved the problem. Unfortunately, there's a lot more complexity there. Some programming languages have special punctuation marks, so you have to instruct your screen reader to read out all of the punctuation. I'll say more about that in a bit. Some depend on white space, so the indentation matters, like tabs and spaces. Others are graphical in nature. I'll talk about that later in these slides. So there's these basic tools for access that persons with disabilities use, these various assistive technologies, but it doesn't mean that just by having these tools available, there are no issues in this space. If we go to low vision users, right, similar things here. So there's text enlargement, there's zoom, and so forth. But again, think of a programming language in which white space is important, or there are punctuation marks that are very similar to one another, or there's certain fonts that are used in resources around that programming language. These various accommodations that a lot of us use on a daily basis doesn't necessarily guarantee access. It's just simply the tools that are used right now. Physical impairments, right? So we're familiar with one-handed keyboards or sticky keys, which is a functionality in most modern operating systems that lets you type with one hand or sometimes with only one finger on a full-sized keyboard. There's things like eye tracking software or gaze tracking, where you can use only the movement of your eyes to manipulate a cursor on the screen. There's even voice-based dictation, right? So there's a great PyCon talk. PyCon is Pycon. It's a conference for the Python programming language, and there's a great PyCon talk in which this gentleman has lost the use of his hands due to repetitive stress injury, and so he spends a lot of time and a lot of work to train his computer to recognize special words and special phonetic sounds to program with his voice. Right? And so it's not that these things aren't possible, but that the variety of solutions are pretty tailored, and I'll talk about that a little bit on the next slide, but that these types of different modalities for interacting with programming do exist and are used by people throughout the world today. The next slide, please. So problems with existing solutions, right? So there's a lot of bespoke solutions out there. There are customized solutions that someone has written for themselves or gotten a friend or colleague to help with. There are everything from screen reader specific scripts to the different editor macros that some folks will use to make life easier because certain toolbars are not accessible or environments are not accessible. And the problem is that these heavily customized solutions might work for one person, but they don't necessarily work for everyone. And even if they did work for others, there's now an awareness problem. So there's these great one-off solutions created. Maybe it can help someone else. For example, that voice dictation software that I was talking about in the previous slide. But if someone doesn't know about it, then it's not very helpful to them. So we need to address this awareness problem of distributing and disseminating information about accessible computing, in addition to making computing itself accessible. I think that's very important. Educational resources are another thing that comes up all the time, right? So it's not only educational resources such as a textbook, which matters. Shout out to Benetech here, right? It's the largest accessible library in the world, and even Benetech doesn't have all of the programming books out there, right? Not for lack of trying. And the thing is that if there are resources out there that are available to others, but not to students with disabilities, and whether it's a format issue or whether it's not being available in larger print or whatever the case may be, cognitive impairments and writing level and things of this nature, this all affects the landscape of who has access to learn computer science. And that really matters because it's a barrier to getting into the field. A lot of times it's power users that succeed, right? So someone who is very familiar with the technology goes through a lot of arduous processes to really survive some various challenges along the way, writes their own macros, writes their own scripts, figures out their own solutions. This is a huge barrier to entry, right? There are many developers with disabilities in the world, but I can safely say that getting into programming was a heck of a lot harder for them than it is ordinarily for a student without disabilities. And so we need to work on leveling the playing field in terms of entrance and lowering this barrier to entry. I have an example here. I wanted to go back to that screen reading example. So on the slide it says even when things work, they don't work great, right? They aren't great, and it's a line of code. It's from C or C++, right? And it's a loop that counts from 0 to 9, so it makes 10 steps, right? But I also have what a screen reader user might hear, and so they'll hear something like for, F-O-R. So they'll hear for left paren int I semicolon. For left paren int I equals 0 semicolon I less than equals 10 semicolon I plus plus right paren open brace, right? And this is just, it's not exactly the most intuitive thing. Andy has done a great deal of work on this. I'll let him talk about syntax. But other programming languages like Quorum, for example, say repeat 10 times. And not only is repeat 10 times a lot easier to read, not only is it a lot easier to feel on a Braille display, not only does it fit in less characters on a line and therefore is better for screen enlargement, but also it happens to have the advantage of being easier to be said. So if you're using dictation, repeat 10 times is something that you don't have to train your dictation software to say special symbols for, instead of all of these semicolons and open parens and curly braces and so forth. Okay, next slide. So problems with current inaccessible solutions, right? So we have a screenshot on the screen here, and I'll do the standard ironic thing where the blind presenter is doing image description. And so what we have here is a game under development, right? And we've got 2 windows. There's a tank driving around a desert environment on the left-hand side. And then on the right-hand side, we have a ton of options, like a ton of menus and options and different customizable things that can occur. And what we're seeing here is something called an integrated development environment, or IDE. And so an IDE like this one, for example, is called Unity, and it's created for making video games. Right? And this makes the job of making video games a lot less difficult than it was 10 years ago. And you can customize everything there is, the physics, how the tank looks, the behavior of the tank when it runs over sand, when it hits an enemy, when it encounters a wall. And you can do these things with just point and click. Scroll through a couple of properties, adjust a couple of values, click over here, maybe write 1 or 2 lines of code. You can very easily start editing and collaborating with others to build a video game. The problem is not that someone who's, let's say, blind or low vision, for example, can't do any of those things semantically speaking, but they can't actually be interfaced. This GUI is inaccessible, this graphical user interface, so it's not usable with a screen reader. Color contrast issues haven't been thought of for people who are colorblind. There's a whole slew of issues if you have mobility impairment and are needing to tab through the controls. And so this kind of tooling needs to be made accessible so that persons with disabilities can be part of the solution-making process, not only for making the technologies of the future, but also for making the accessible and assistive technologies of the future. All right, so next slide. This is another example of inaccessible solutions to date, right? So we have a block-level language here. Block-level languages are simply a way of saying that instead of writing code, instead of writing programming language in a text editor or in an IDE and manipulating that text, what you're doing is you're manipulating blocks on the screen. And these blocks can have behaviors. You can put a bunny on the screen or a cat on the screen. You can then give it a jump action. And so it's really sometimes aimed at getting kids into programming because it's a little bit easier, or at least that's where the thinking is, as opposed to writing text, writing arbitrary text. But the problem, again, here is this is kind of like a video game, right? So we've got a block on the screen. There's arrows. There's things you can manipulate. There's things that move. You can drag other things and drag and drop on top of, other sections of the screen and rearrange. And all of those actions really basically assume you can see and move a mouse. And that excludes not hundreds of thousands, but literally tens of millions of users at that point. And so if this is going to be the first exposure to computer science for somebody in third grade, somebody in middle school, right? You really have to think about the isolating effect of this, and the idea that if they're thinking, oh, computer science is moving blocks around and doing these things, and I wasn't able to get anything out of that lesson at school, then maybe computer science is not for me. And that's another fundamental aspect of making this tooling accessible that we really need to concentrate on. Okay. So next slide. So how can we make things better? We talked about the tooling problem on the previous slide, right? But there's also an issue around the inputs and the outputs. This is the stuff that Stefik's going to talk about after this slide. So I'm going to turn it over to him in a second to talk about those things, but it's just important to realize that it's not only the tooling that needs to be made accessible, it's the inputs into these things, like the programming language. It's the outputs of these things, like if you make a video game, will it have sound in 3D that someone who's blind or low vision can use? And can you manipulate the colors so that someone who's colorblind can just simply flip a flag and actually be able to play the same game without a lot of complexity going into that decision. There's all of these considerations to be made when we're thinking of computer science accessibility, in addition to the resources and everything else around the educational and professional resources that we've talked about. The one comment that I will make here in closing is, next slide, please, sorry. So is why does this matter, right? And this is tradition. Oh, excuse me. If we can actually go back to the previous slide, sorry, Amaya, how we can make things better. You'll see a screenshot on this slide as well. This is Richard mentioned Bootstrap earlier. There's a programming language, WeScheme, and in WeScheme, they're working on making a block level language. So like the one we saw in the previous slide with blocks and arrows and so forth, same idea, but instead, as the Bootstrap folks are working on this is Emmanuel Schanzer's work, it's actually being made accessible. And I've been working with them. We've now got full keyboard access, screen reader support, ARIA for the browser, etc. Things talk automatically when you want them to, and you can navigate everything with a variety of different input modalities to make this kind of block level programming language accessible. So this stuff is easy. It's able to be made accessible if folks try, and especially the earlier you try to make these things accessible, the better off you'll be. So last slide here. Why does this matter, right? So this is traditionally the slide you might, start off a conversation with, but I chose to put it at the end to springboard to, Andy's section, basically. But really quick, I'll just touch on a few things here. Persons with disabilities, and I mentioned this earlier, need to be part of the solution-making process. If we are not allowing students with disabilities to get into programming and to start solving and contributing to the solutions for their own problems, then it really violates that sort of advocacy principle of nothing for us without us, right? And this is really important, that you need the user's voice, and if they want to then contribute to the solution, we need to make computer science available to everyone so as to allow them to do that. By facilitating access to computer science, we're not only giving them tools, we're giving students tools to, help get assistive technologies written for themselves, but to generate technologies for their friends and colleagues, right? And that's incredibly important as well. And Richard already talked on, the jobs aspect of this. Millions of jobs, 1.2 million jobs are going to be in this field. And so it's incredibly important to make sure that students with disabilities, we don't lose an entire generation just because some of these tools are inaccessible or some of these curricula are not available to them. And the last point that I'll make here is that institutional inertia matters. If we can get more and more people through webinars like this one, through the amazing work that Richard and Andy are doing in this field, if we can get more people thinking about inclusive design and accessibility in programming and in computer science, eventually this becomes something where it's actually harder not to make things accessible than to make them accessible. We're not there yet at all. But it is definitely going in that direction, and the more people we can get to participate in thinking about making these things inclusively designed, the more we can start building that inertia so that then it becomes a normal thing that someone considers when writing the new programming language or writing a new gaming environment, etc. So with that, I will turn it over to Andy to talk about the amazing work he's doing in this space.
All right. Can everyone hear me?
Yes.
Okay, great. So thanks to Richard and Sina for your sections of this, and for Amaya for inviting me on the talk. I appreciate it. One thing that I was asked to speak about today is in part what I call the Quorum project. If you've never heard of this before, Quorum actually is a computer programming language. It's sort of essentially a program that can translate information into ones and zeros that the computer can understand. And this actually started in 2009 as part of a National Science Foundation grant to try to make programming easier for blind and visually impaired people. This was actually the only goal of the project until up until about 2012, and as such, we could argue maybe that it was born accessible, that it was designed specifically for one group. At the time, we were spending a lot of time talking to people that were blind and visually impaired, and just asking, what would help you, what would be helpful to you, including Sina Barang, who's actually on this call and on this slide. So if you've never heard of Quorum before, I'll give you a little bit of information about what it is and how you get it and stuff like that. First, as a programming language, you can get all of the supporting materials for free, especially teachers across the United States and several other countries as well make heavy use of this. The language itself is free for any purpose, commercial or non. The standard library, basically all the stuff that I'm going to tell you about that we've built, is also free for any purpose, educational or otherwise. We have a rich community of teachers and professionals that both develop and vet curriculum and tutorials for us, and they have generously put all of that material under Creative Commons so other teachers can give that. We have lessons for the classroom that are mapped to the major initiatives that Richard was speaking about, like computer science principles. And we have all sorts of lessons and tutorials on fun topics, like how do you do computer gaming even if you have disabilities? How do you use Lego robots if you have disabilities in general? Now, Quorum, even though it started technically as a born accessible project just for the blind, many of the tools that we've made have actually been picked up by the general education population as well, so much so that when Quorum first began, I think the first class taught with it had perhaps 4 or 5 students, and there was 2 teachers. By 2016, there's about 40 schools, to my knowledge, that use Quorum in the classroom, that ends up being in the ballpark of around 2,500 students, and that's about half of just general education classrooms, and half represented from the residential schools for the blind community. One of the reasons why it's been becoming increasingly more popular is because Quorum is designed not just as a toy. It has sort of extensive libraries for doing commercial scale computer programming in general. So extensive multimedia libraries for gaming and otherwise, extensive documentation, and also easy to use mechanisms. So for example, if you want to output through text to speech in a typical programming language, it's actually quite difficult to create that. In Quorum, you effectively just use a command called say, and it will take care of those kind of details for you. So what does it actually support? Well, one thing is that we've created technology to make 2D and 3D graphics programming accessible, even if you're totally blind. How that actually works is sort of complicated outside the scope of the talk, but we have a technology to do that. On our back end, we're able to do that using hardware acceleration, even if you're in the browser, which will come out in the fall. And we're trying to do very complex topics, even if you're totally blind. So for example, embedded physics or complex algorithms like that, even if you can't see it. We have multi-platform support, so it's on Windows and Mac. It runs in a browser, or at least it will soon. That'll be released in June, even though it's already finished. We can compile Quorum to the iPhone as of last year, and we're hoping to have Android support by next year as well. We have extensive support for things like Legos, music, libraries, IDE support that is also accessible. It's accessible on the web and other places as well. The point is that Quorum is not a toy, but on the other hand, it's designed to be as commercially scalable as possible, but as easy to use as we can make it in order to make it applicable to the widest audience possible. So in general, I want to give you an example of that in how we try to make things easier. So consider, for example, writing an audio system and doing it using commercial scale applications, one of which is called OpenAl in C++. And some of the things you might do with this would be make a sound and spin it around your head in positional audio, or do distance attenuation as the sound gets closer or farther to you, or simulate Doppler effect when it goes around the scene, like wow, stuff like that. Many of these kind of features are actually only really available in commercial applications, so they're generally not the kind of thing you would see in educational tools like Scratch or tools like that. So if I have C++, one barrier to young students is that, in fact, in order to use a tool like OpenAL, you have to know linear algebra, which is generally taught around maybe the second or third year of a college sequence. Oftentimes, the naming conventions that programming language designers use to create these things make very little sense, and often moving platforms from, say, the desktop to the iPhone to Android is a tremendous barrier for students. So here's a tangible example of using OpenAL. On the screen, I have about 10 to 15 lines of code, and all this code really does is play a sound. But in order to do that, I have to use techniques like AL listener FV, left paren, AL underscore position, comma, listener position, right paren, semicolon. There's about 10 other lines that are like this, and OpenAL basically puts it in this format because they sort of assume that the reader or the writer of the source code understands these sort of deep mathematical concepts. But here's the thing. It doesn't really have to be this difficult even to represent the mathematics. So if you take an example like Quorum, doing exactly the same thing, load a sound, prepare a sound, set a sound's position in 3D space, kind of like a grid, and then play it, you might say words like use libraries.sound.audio, audio birds, birds load, enable looping, set its position, or birds : play. You use basically words that are designed to make sense to human beings as opposed to make sense to a computer in order to represent the kinds of commercial scale operations that you do. Now, at this point in the talk, I'm going to transition just a little bit to say how we actually go about that, and it's going to sound sort of coy, and that is we use the scientific method, right, to make things easier. And that sounds easy to say, except when we were first investigating how to make things easier for human beings when using programming, we found something rather odd when we were working with blind programmers. And that is we weren't finding much evidence. So in order to explain what I mean by that, I'm going to give you just a quick primer on what it means to have evidence, and then I'm going to tell you what actually exists in the field today in terms of even in academia. And I'm pulling this from several books that are on the slides. One is a paper by a fellow named Ted Kapchuk, and another is by a fellow named Harry Marks on how experiments were designed. So really quickly, experiments in science really started taking hold more explicitly by the late 1700s. So Benjamin Franklin was investigating something called mesmerism, which is effectively this sort of sham or fake scientific idea. And at the time, this king, Louis XVI, actually hired Benjamin Franklin and a group of scientists to detect whether this was effectively nonsense. And they used a technique that eventually became known as effectively placebo, and they called it sham treatments. This sort of continued in other fields. So one really famous test was the Nuremberg salt test of 1835, which evaluated this thing called homeopathy. There was a doctor at the time named Friedrich Wilhelm von Hoven, and he basically considered it to be a dangerous fraud. And so they conducted an experiment in 1834 that was actually very similar to modern experiments. And there were some other individuals at the time, Armand Trousseau, people in the late 1880s that did similar experiments. But really, in science, the field of experimentation had two really fundamental contributions in the 20th century. One was this fellow named Ronald Fisher effectively created statistics, or how we know it now. And there was a doctor named Austin Bradford Hill that had these ideas called precision and coherence. Basically, the idea was that even though running experiments and using evidence and data is not perfect. There will be mistakes in science. Over time, communities can make progress and make more precise judgments by using experimentation in a way that's consistent across the field. And other fields have codified these into formal evidence practices. So, for example, in medicine, between 1990 and 2001, there was 110,485 experiments that had a certain classification, and they have formal evidence standards called Consort. So the idea is different fields have evidence standards and use techniques like what are called randomized controlled trials to try to find evidence in terms of what they're actually exploring. Now, computer science being a modern scientific discipline, you might assume that if medicine did 110,000 or so experiments in 10 years, that computer science is actually quite similar for programming languages. So in fact, that's totally true. We have, in fact, from 1950 to 2012, we have a total of 22 experiments, which is slightly lower than 110,000 over a 10-year period. And this sounds rather odd. Programming languages are, in fact, the entire foundation of evidence of how we build, the foundational technology for how we build nuclear reactors, how we build websites. When something gets hacked, was there evidence about the language constructs that were used? And so one thing that we did on the Quorum project by observing blind programmers was we figured out that maybe we need to start a paradigm and start pushing in academic circles the concept of using evidence. So we did that. And we've created something called evidence-oriented programming, where changes made in the Quorum programming language, we use randomized controlled trials to investigate the truth. We allow external authors as a community to put forward evidence to convince the development team to change it. We use evidence from other techniques like field studies or software repository mining, educational data. As long as it's gathered from humans and rigorous, that's sort of allowed, sort of Bradford Hill's coherence idea right there. And then because we work with teachers and we know that evidence might change the language over time, we put that on a development cycle so that basically whenever we make changes to the language, it corresponds with what teachers naturally do, which is basically have summers off so it doesn't get in their way. So let me give you a couple examples, one of which came from Sina. This example he gave of for left paren int I equals 0, semicolon, I less than 10, semicolon, I plus right paren left brace. This actually the changes that we made to repeat 10 times came from survey data at scale. So we ran surveys on how humans interpret the various words and symbols that are in the language and found that even novices can understand words like repeat, but the three worst choices that they claimed would not make sense for the concept of iteration were for, while, and for each, which is actually ironic because most programming languages use those three words as their symbols of choice. We've also done these things called sham treatment experiments, very similar to how Benjamin Franklin did his experiments back in the day. And in that particular case, we found something, again, rather odd. We did an experiment where we basically randomly designed programming languages. We rolled dice in the lab or used a random number generator. And when we do that, we compared the initial use of the language to several other languages like Ruby and Python, Perl, and stuff like that. And as it turns out, Java and Perl do no better for novices than a programming language where we generated it randomly. Now, that might seem esoteric until you realize Java is actually the computer science AP standard in the United States, a language that has been so thoroughly not vetted that we can randomly design a language and it's just as easy to use, according to the data.
Stefan,
yeah.
This is Richard. I wonder if you could skip to the last slide so that we can answer questions.
Oh, there's two left. So, but yeah.
You're taking a little too long on each one. So.
Okay, sorry. Well, in any case, the point is Quorum uses a scientific process that's vetted by a community to try to gather evidence on what is easy or not easy to use for actual people, including those with disabilities. In other words, it's not just a guess. So if you're interested in this or the projects that we have going on in the labs, we have mailing lists, Facebook things you can get more information. All the materials and tutorials and curriculum are all free for use. And you can go to quorumlanguage.com if you want more information. And that's all.
Thank you guys so much. I know that was a lot, so I do want to open it up to questions. I'm going to try to unmute everybody. Sometimes that doesn't work and just makes a cacophony of horrible sounds. So then I'll remute people and we can go with typing questions in chat. But let's try the unmute function. So here we go.
The conference has been unmuted.
So I would ask that if you don't have a question, you can yourself. And does anybody have any questions?
Hello?
Hi, yes?
Hi, it's Allison.
Hi, Allison.
Hi, I have a question if nobody else does.
Yes, please.
Okay, I don't know if anybody can hear me because there's a lot of background noise.
There is a lot of background noise. Can people mute themselves?
Could I actually, why don't you mute everybody and unmute Allison? That might just work.
Okay, I can do that. 1 second.
The conference has been muted.
I just realized, Allison, can you raise your hand? I realized that you've dialed in and I don't know what number to unmute. And if anybody else has a question, you can go ahead and raise your hand. While we're waiting for Allison, here's one that's come in from Michael. Can a program in Quorum be converted to JavaScript so as to be able to use in HTML?
In Quorum 5, yes, we just finished that. And that includes all of the game libraries and audio libraries and other stuff as well. There are a few limitations to what you can do to convert in JavaScript. For example, you can't actually use the Lego robots from within a browser, but a significant majority of the tools can be done automatically as convertible. So yes.
Jesse Black asked, will we be sent a link to the presentation? I will be sending out a recording of the presentation to everybody who is registered, as well as posting on our website as soon as we get them captioned and do accessibility checks. Rachel asks, could Quorum be used in 3D printing software to create STL files?
I'm not sure, actually. So Quorum can load in 3D models, which I think are very similar to STL, but we don't have a library to send it to a printer. So I'd have to investigate more carefully, but I don't think that would be super trivial, but I don't think it would be the end of the world to make it work either. So remember, too, Quorum's a programming language, so you can actually do anything with it, but I'm just thinking of things that are just right out of the box. And I think the answer is not out of the box.
Stefik, I'll go one step further than that in that, you and I have talked a little bit about actually using the accessibility that's in the video game library, especially the 2D and the 3D accessible stuff that we've been talking about a lot, to explore 3D models. And so one approach would be to possibly simply have this bridging technology whereby if we could translate those 3D models to STL, you could not only explore a model tactily because you can hold it in your hand, but also virtually on the keyboard or with your mouse or whatever through the video game library as well.
Yes, that's totally true, for sure.
So Eric asks, is there a clearinghouse of information regarding the different IDEs and their accessibility status for different types of disabled users?
I'll take that one, I suppose. This is Sina. So the short answer is no. The slightly more helpful answer is that there's various communities out there. The Program L listserv, I think it's Program -L if I'm not mistaken. There used to be a blind programming mailing list, and a lot of folks moved over to the Program L listserv. That is pretty concentrated. There's a large population representation of the programmers with disabilities, especially blind low vision ones on there. Stefik actually posts on there to help people publicly with Quorum. I'm on there, and so that would be one place to go to ask about these different questions and to get different points of view from folks who use a variety of different assistive technologies. There's other groups as well, but as far as an official clearinghouse, none comes to mind, other than that which people just talk about kind of informally, like folks might ask me or email me or tweet me, and others in the field. Hey, what do you use? What's accessible, for someone using this assistive technology, et cetera?
Can I add to that? This is Richard.
Yeah.
So my student, Katie Baker, did a little survey of ID as to their accessibility. It's not published. It's going to be in her dissertation. But I can try to get that table for you. Eric, just send me an email. Thank you.
So Michael says that he would like to access surface data from NASA for the Martian or lunar surfaces for conversion to STL for 3D printing. I think that's more just for our knowledge, so we will note that.
Although it does bring up a point, which is that this year the EPIC programming language, the EPIC programming conference, which is experience programming in Quorum, which is held every year. Quorum, Andy talked about this briefly in his slides. Will be held at the Yerkes Observatory and so astronomical data and access to astronomical data is actually becoming an even increased higher priority in Quorum. I don't know, Andy, if you want to say anything further about that, but that's a pretty exciting development.
So in terms of NASA data, we don't have anything for converting to STL. That's actually the same answer as before. However, we're definitely doing a lot of work right now on trying to figure out how to make astronomical data more accessible. And so that's a collaboration called iData. It's in collaboration with University of Chicago, Yerkes Observatory, and there's a group out of North Carolina, Chapel Hill, that actually has a group of robotic telescopes worldwide that you basically send information to and it'll take a picture for you. And this initiative actually just started last fall, and this summer at Yerkes Observatory at EPIC is when we're going to be showing off some of that tech for the first time. I will say, though, for people that are interested in various kinds of things like 3D printing or other stuff, you're definitely welcome to join the Quorum mailing list and make requests, because our team does actually track what people in the community want, because it helps us figure out what we should do for our next releases. So if you have questions like this, you're always welcome to mail us by mail as well.
And if you're curious to know who Andy is, or Stefik is, or Andreas is, because I think we keep referring to all three of those names, it is the same person.
Yeah, this is Richard. I see Allison got her question in finally about your daughter. That's great. I think one thing to think about, Allison, is that there is...
Richard, if you want to repeat the question really quick before you...
I'll repeat the question. My fault. Allison, says, I'm the parent of a low vision child. My daughter will enter kindergarten in the fall of 2021. What can I do now to ensure that her local school will implement Quorum and other accessible options into their coding and computer science instruction by then? This is Richard again. Yeah, so good that you have a few years to prepare. And I will mention there is a framework, K through 12 framework that has just come out, and I think I didn't put that into my list of things to show, but I will add that into the slides. Also, the CSTA has a K through 12 framework, or K through 12 curriculum. So definitely you should point those things out to the school that they're going to go to, and it does include kindergarten. And then from that point on, I think you just have to advocate and say, yes, is this accessible? Will my child be able to do it? And then having their knowledge of quorum, you can say, well, there is this language called quorum that is accessible. Can you use that instead of something else? And so I think just strong advocacy by you will really help a lot.
Thank you, Richard. And Michael asks, can quorum be used with microcontrollers like Arduino?
Off the top of my head, I'm not sure, because I don't know what Arduino uses on the back end, but I will say quorum can compile to a bunch of different infrastructures. So, it can convert itself to write on various places. One of them is the Java virtual machine, so if the Arduino supports Java, then very likely it would work there. If it supports JavaScript, we can convert to that. Oh, uses C. Okay. Well, I'm not sure. It depends on what other stuff is on there. If that's, we haven't investigated ourselves whether it can be used on that, because I just haven't tried it. I don't have an Arduino. I think they're cheap. But so if you're interested in us getting support for that, toss us a mail on the mailing list, and we can look into it. So we usually track how many requests there are for various things on there. So, okay, cool. Yeah, thanks. Thanks for the question, too.
Mm-hmm. So we've hit time. Before we sign off, are there any last-minute questions or anything? Again, if you go ahead and type them in the question box, if there's only one or two, we can answer them now. Otherwise, we'll answer them after the presentation and get those answers out to everyone. No? Going once? Going twice? All right. Well, in that case, I just want to say a huge thank you again to Richard, Sina, and Andreas, or Andy, or Stefik, as he for presenting. I think this was just a fascinating topic, and it's something that Diagram Center is working really hard on exploring more. So thank you guys, and thank you all for joining us. I will send out an email once the presentation slides and the recording are available and on our website. So thank you, and enjoy the rest of your day.
Thank you all.
Thank you.
Bye, everyone.